All right. So, in yesterday's class, we have been doing determinants. And we got to know what is a 2 by 2 determinant. Then we got to know, say this is a 2 by 2 determinant. Then I told you about the 3 by 3 determinants. Then minors of the elements of a determinant. Then cofactors of the elements of a determinant. Yes or no? Then we have done the value of the determinant. And in that case, I told you, if elements of any row or any column be multiplied by the respective cofactors of same row or same column and then added, then we get the value of determinant. Yes or no? But if the elements of any row or column be multiplied by the respective cofactors of any other row or column, then we get the value 0. Remember this thing? Then we came with the application of determinants, like we use it in the cross product, area of a triangle. Then we have done a question on area of triangle, one question on collinearity of 3 points. So if 3 points will be collinear, area formed by those points will get 0. Is it okay? Now we'll start with today's content. And the content today is very important. That is properties of determinant. Properties of determinant. So first of all, first property. So properties of determinant may tell me what are the properties of determinant? Any idea? Have you studied somewhere? Abhishek, Srinidhi?
No, sir.
See, first property is value of determinant becomes 0 if elements of any row becomes 0 or column. So if all the elements of any particular row or any particular column, if all the elements become 0, the value of the determinant goes 0. Correct? If all the elements of any row or column become 0, the value of the determinant gets 0. Second property, value of the determinant does not change if rows and columns are interchanged. Value of the determinant does not change if rows or columns are interchanged. Means what? Like what happens in matrices, if I change the rows of the columns, I get the value transpose of the matrix. Remember that? But the value of that determinant won't change. That means if you have a determinant D as ABC, PQR, XYZ, then we have a determinant D dash as ABC, PQR, XYZ. And determinant of D will be determinant of D dash. Is it fine? Is it okay? Third, with respect to every square matrix A, there is a term associated that is determinant of A, or sometimes determinant of A. So with respect to every square matrix, a term determinant of A is associated. And if determinant of this matrix is 0, what do we call it? We call it singular matrix. And if determinant of A is non-zero, what do we call it? We call it non-singular matrix. Got it? So if determinant of A is 0, we call it singular matrix. If determinant of A is non-zero, we call it non-singular matrix. Now, fourth term. Say you have a matrix A as 0, A minus B, minus A 0, C, B minus C 0. Can somebody tell me what special kind of matrix this is? Yes, anybody? Is there any particular variety behind this kind of matrix?
Sir, is it a skew matrix?
Yes. This is a skew symmetric matrix of order 3. Correct. Now I take A transpose. Say I take determinant of A transpose. That will be make the first row as first column 0 A minus B minus A 0 C B minus C 0. Now in case of determinant, what do we do? If we multiply with something, we multiply in any row. If we take common from something, we take common from any row. So that means if I take minus common from all the 3 rows, it will be minus 1. It becomes 0 A minus B minus A 0 C B minus C 0. And that became minus of determinant of A. Now, in the previous property, I just told you that determinant of A transpose is equal to determinant of A. So determinant of A is minus determinant of A. That means determinant of A goes 0. So the main property behind it is if A is a skew symmetric matrix of odd order. If A is a skew symmetric matrix of odd order, then determinant of A will be 0. If A is a skew symmetric matrix of odd order, its determinant value will be 0. Write down very important property. If A is a skew symmetric matrix of odd order, its determinant value will be 0. Understood? क्या ये बात समझ में आई? Everybody understood? Yes, Gautami, please speak up.
Yes, sir.
Gautami, you want to say something? Now, property 4 के बाद property number 5. If a determinant is multiplied by any scalar, if a determinant is multiplied by any scalar, it gets multiplied in any of its rows. If a determinant is multiplied by a scalar, it gets multiplied in any of its rows. Now, what does it mean? Say you have a determinant A as ABC, PQR, XYZ. Now you are multiplying this matrix, this determinant A by K. Then what do? We multiply K in any of the rows. So KA, KB, KC. Now it is PQR and now it is XYZ. Whereas what happens in matrices, if you multiply a matrix by a scalar, it gets multiplied in its every row. If we multiply a matrix by a scalar, it gets multiplied in its every row. That means if we have a matrix P as ABC, PQR, XYZ, and if you do KP, so K will be multiplied in all the elements. So KA, KB, KC, KP, KQ, KR, KX, KY, KZ. Understood? So what happens in a matrix, if you multiply it by a scalar, it gets multiplied in its every row. It gets multiplied in its every element. But if a determinant, if you multiply it by a scalar, it gets multiplied in any row. That means, see, if P is a matrix of order 3, then determinant of Kp will be K cube determinant of P. Because while calculating determinant, first you multiplied K in the matrix. Now if you are trying to take the determinant, then you can take K common from each and every row. So Kp is determinant is K cube into determinant of P. This is a very popular question in boards also. Like a question if I ask you, given for a matrix P of order 3. Given for a matrix P of order 3, determinant of P is 3. Find the value of determinant of 3P. Yes, what it is? Tell me. Find the value of determinant of 3P. Very
27.
good. Yes, yes. Anybody? Tanush, what are you saying?
27.
81. See,
Yes, sir, it's 81.
determinant of 3P will be 3 cube determinant of P. And determinant of P itself given to you as 3. So it will be 3 to the power 4, 81. Understood? Now property number 6. In a determinant, if any two rows or any two columns are identical in a determinant if any two rows or any two columns are identical, the value of the determinant becomes 0. That means if I talk about the value of the determinant of ABC, XYZ, then its value goes 0. Correct? And this can be easily achieved if you expand this determinant along the third column. Understood? Now seventh. If each element of any row is sum of two elements and sum of two elements, then determinant can be expressed as sum of two determinants keeping other two row unchanged. That means if we have a determinant like a plus x, b plus y, c plus z, L, M, N, say PQR. So keeping two rows unchanged, you can express is as the sum of two determinants. So A, B, C, L, M, N, P, Q, R. And here also X, Y, Z, L, M, N, P, Q, R. If you realize that this row is not changed throughout, you have just splitted this row and made two determinants. So this is the only way if you want to add two determinants or if you want to subtract two determinants. Getting my point? So like if you want to add two determinants, first of all, its two rows or two columns should be identical to the other one. Getting my point? Then you can add or subtract along the third row. And now eighth property, which is very, very important, which is a, I should say, jackpot property in this overall scenario. The value of the determinant, does not change. The value of the determinant does not change if in the elements of any row or column we add or subtract the same multiples of any other row or column. Understood? Understood? So value of the determinant does not change if in the elements of any row or column we add or subtract the same multiples of any other row or any other column. That means अब जैसे you have a determinant A, B, C, P, Q, R, X, Y, Z. Then you say, I have told you this is row 1, this is row 2, this is row 3. Now you apply an operation. Row 1 ko you want to write row 1 plus 3 row 3. So your row 1 will become A plus 3x, B plus 3y, C plus 3z. It is PQR, it is XYZ. And the value of both the determinants is same. Like using the previous property, if you split it into two, one will keep ABC, which is the original determinant. Other will be 3x, 3y, 3z. If you take 3 common, its first row and third row will be identical, value will be 0. So they are identical. Got it? Similarly, you can apply the operation after that, like you do C1 ko you write C1 plus C2. So now what will be your C1? So A plus 3x plus B plus 3y, it is P plus Q, it is X plus Y. So this is P plus 3y, Q, Y, C plus 3z, R, Z. Is it okay? But remember one thing, kind of operations which are not allowed. Kind of operations which are not allowed. Now, what kind of operations are they? Say, kind of operations which are not allowed. Say R1 ko you write 2R1 plus R3, not allowed. The row in which operations are being implemented or applied, its coefficient should be 1. Then say operation like R1 ko you write R1 plus R2, R3, not allowed. Or say operation you do C2 ko you write C2 plus C3 square, not allowed. Or you write R2 as R2 plus C2, not allowed. Row-wise operation will go row-wise only. Column-wise operation will go column-wise only. Got it? So these kind of operations are not allowed. Correct? But this is very important property. Most of the questions, see, this is now no more in the board syllabus, these properties. But most of the JEE questions, they are dependent on these properties only. Now see question number 9. If by putting x equals to a, the value of the determinant
Sir,
yes,
sir, explain the 8th property again, sir.
explain which property?
8th property.
8th property is simply saying that the value of the determinant does not change if in the elements of any row or column we add or subtract the same multiples of any other row or column. Like एक determinant ये है, इसको हम R1, R2, R3 बोलते हैं. Now I'm applying an operation में R1 को I'm writing R1 plus 3R3. Means in the elements of R1, I am adding the third multiples of row 3. In R1, I am multiplying the third multiples of row 3. So you get this? Yes or no, Abhishek?
Yes, sir, I got it.
Motilal, what are you saying, beta? I did not understand. Why not, sir? Why not R1 plus R2, R3? Because these kind of operations, if you apply, and they won't result into same determinant. Getting my point? When you split a determinant, it should give you the original determinant also.
Okay,
Like,
okay.
if this one you split, say graph में करके देखते हैं, let's do it. This one you split, one will be A, B, C, P, Q, R, X, Y, Z. Other will be 3X, 3Y, 3Z, P, Q, R, X, Y, Z. See, if you take 3 common from first row, it will be X, Y, Z, X, Y, Z in first and third row. So that value will become 0. So determinant of value जो यहाँ थी, the same is here. Value of determinant does not change. Understood now?
Yes, sir.
So now ninth property. If by putting x equals to a, the value of determinant vanishes, then x minus a is a factor of the determinant. If by putting x equals to a, the value of determinant vanishes, then x equals to a is a factor of the determinant. Am I clear? Now see, let's do few questions. One question if I do, one x square, one y square, one z square. This is equals to x minus y minus z minus x. Got it? So first of all, I'll teach you how do we expand it. Then I will also insist you to remember this result. See, let's start with LHS. 1x square, 1y square, 1z square. I'm writing a property. Let us take R2 as R2 minus R1. So R1 is 1x square. Now, if you do R2 may, you are subtracting R1. What do you get? 0, y minus x, y square minus x square. Correct or wrong? Simultaneously, let us apply R3 ko I write R3 minus R1. So when you do R3 minus R1, you get 0. This is z minus x. This is z square minus x square. Got it? So now from this second row, can you tell me what can I take common? From this second row, what can I take common?
Y minus x.
Y minus x. From this third row, what can I take common? Z
Z
minus
minus
x.
x.
So if I take y minus x into z minus x common, it will be 1x square, 0, 1 y plus x, 0, 1 z plus x. Now, expand along first column. So if you expand along first column, already 2 entries are 0. So the value directly you are going to get y minus x, z minus x. This is gone, this is gone. It will be z minus y. Now take minus common from this one, make it x minus y. Then take minus common from this one, make it y minus z. And finally z minus x. So this minus minus became positive. Correct? Am I clear?
Yes, sir.
Now, let's have a look at it quickly. Done?
Done, sir.
Like a, like a simple question if I ask you. The question is, if A, B, C are the sides of a triangle and determinant of 1a square, 1b square, 1c square is 0. ABC are the sides of a triangle and 1a square, 1b square, 1c square is 0. Then what type of triangle it is? Then what kind of triangle it is? Tell me quickly. Yes, anybody?
Don't know, sir.
See, just now I told you the result of this matrix, this determinant. 1a square, 1b square, 1c square is 0. This implies a minus b minus c minus a is 0. Yes or no?
Yes, sir.
Now, if they are 0, this implies what? A equals to b or b equal to c or c equals to a. So if it is happening, that means what? Triangle is
Equilateral.
not equilateral, isosceles. Or है ना?
Same length.
Either this or this or this. So triangle is isosceles. Definitely if equilateral is it is equilateral. These conditions are also valid. But equilateral is a subset of isosceles triangle. So larger case is isosceles. Understood? Now say there is a question. Prove that 1a cube, 1b cube, 1c cube. That is a minus b minus c minus a, and a plus b plus c. Give it a try using same method, same. Yes, quickly. Now, first of all, again, same approach, same. See the solution. But they provided you 1a cube, 1b cube, and 1c cube. Now let's apply the operation. R2 ko you can write R2 minus R1. R1 is 1a square, R2 will be 0, b minus a, b cube minus a cube. Zero, c minus a, c cube minus a cube. Correct? Now if you see, from this column, you can take b minus a common. From this column, you can take c minus a column. So take the b minus a and c minus a common. You are left with 1 a square, 0, 1, b square plus a square plus ab, 0, 1, c square plus a square plus ac. Understood? Now, simply what expand along? First row, first column. So if I expand it along the first column, you get your desired result. That is a minus b, b minus a minus b, b minus c minus a into a plus b plus c. Understood? Is it okay?
Okay, sir.
Now, next question, लिखो जी. Prove that determinant x, y, z, y, z, x, z, x, y. Prove that this determinant is with negative sign a, sorry. Have I told you this earlier? Okay. Now, this is equals to with a negative sign x plus y plus z, x square plus y square plus z square minus xy minus yz minus zx. And more importantly, this is also equals to x plus y plus z, x minus y whole square, y minus z whole square, z minus x whole square upon 2. You guys give it a try. I'll be back in a moment. All right, everybody. So have you given it a try? Okay. Some of you was asking for, sir, can you explain how to expand? Ramaksha, were you not there in yesterday's class? Akshay?
Sir, I have network issue, sir, yesterday.
Okay, so do one thing. First of all, this entire lecture is available on the YouTube also in a video. There is a YouTube channel named Avanti Live 3. Akshay, am I audible to you?
Yes, sir. Yes, sir.
So are you aware of that YouTube channel?
Yes, sir.
So there's a YouTube channel available where you can watch the entire lecture of yesterday. Still, for your sake, I'll explain it once. How do we expand a determinant? So I told everybody that if elements of any row or any column be multiplied by respective cofactors, elements of any row or column be multiplied by respective cofactors and added, we get the value of determinant. Like this is a determinant. If elements in the elements of first row, I multiply the cofactors of first row and then I add them. If in the elements of any row, I multiply the cofactors of same row and add them, we get the value of determinant. Understood?
Yes, sir. Thanks, sir.
Now, see this question. Any idea? Anybody who have tried it? See, LHS I start with determinant x, y, z, y, z, x, z, x, y. All right. Let's apply an operation, right? C1 as C1 plus C2 plus C3. So what is the entire C1? X plus Y plus Z. Y plus Z plus X. Z plus X plus Y. Then Y, Z, X, Z, X, Y. Now, is there anything you can take common from the first column? That is exactly X plus Y plus Z. Let's take it common. So it is 1 Y Z, 1 Z X, 1 X Y, correct? So first of all, I applied C1 is C1 plus C2 plus C3. Then I took that X plus Y plus Z common. Now the three ones are there. Now write R2 as R2 minus R1. So no change in X plus Y plus Z. So 1 Y Z, 0 Z minus Y, X minus Z. And write R3 as R3 minus R1, 0, X minus Y and Y minus Z. Now simply expand along the first column. So X plus Y plus Z into Z minus Y, Y minus Z, minus X minus Y, X minus Z. So take minus common and you multiply the entire expression. You get X square plus Y square plus Z square minus XY minus YZ minus ZX. Understood? Have a look. Done? Now what all have we done today? We were dealing with the properties of determinant. First property that I told you that the value of determinant becomes 0 if any row is totally 0. If a row is 0, the value is 0. Then value of determinant does not change if rows and columns are interchanged. And from this we have derived that the determinant value of a skew symmetric matrix of odd order, like third order, fifth order, so its determinant value will always be 0. Next, with respect to every square matrix A, there is a term associated determinant of A. And if determinant of A is 0, we call it singular matrix. If determinant of A is non-zero, we call it non-singular matrix. Correct? Now, if a determinant is multiplied by a scalar, its any row can be multiplied by that scalar. Got it? Whereas if we multiply a matrix by a scalar, its every entry should be multiplied by the same scalar. And the same thing I have explained. This is with respect to determinant. This is with respect to matrix. And then a very, very important property we have done this. Like determinant of Kp is K cube determinant of P. Now next, given for a matrix P of order 3, determinant of P is 3. The value of determinant of 3p, that would be 3 to the power 4. Now in a determinant, if any two rows are identical, value of determinant is 0. If in any row, same multiples of any other row are added or subtracted, the value of determinant does not change. So these were the properties of determinant. On the behalf of that, we have done 3 questions that I insist you that you should remember. This expansion, other is this expansion, and the other one is this expansion. Will you be able to do it now, everything?
Yes, sir.
Well, and now you can also start practicing questions from the determinants chapter of Avanti volume. Fine. In the next class, we will do few questions on these properties of determinant. Then afterwards, we will move forward towards the matrices once again. All right. That would be all from my side today. Thank you so much. And do more. Try, keep trying. Every time, keep trying. All right. Thank you so much.